equations, the basics. Here's a rough definition of what it means to solve. Find the value or values for the variable that make the equation true. You can only solve equations. You can't solve an expression unless it's equal to another expression. Here's two examples. X is basically a mystery number. We want to know what value could X be to make this true. So how big does X need to be so that when you subtract 92, you still have 5 left over? Well, since 97 works, and it seems to be the only number that would work, that's the solution. We write the answer as X equals 97. In this one, some number squared makes 9. Well, there's actually two possibilities. X could be 3, but X could also be -3. So they're both solutions. Now let's experiment with this. It's a very basic true statement. Here's what I want to point out. If we do math to one side of the equation, like adding 2, it changes the equation so that it's no longer equal. But if we take that same equation and we do the same math to both sides, it's a new equation, but it's still equal. We've shown that we can add to both sides. What else can we do? Well, let's subtract something from both sides and see what happens. Still equal. You can also multiply by things as long as you do it to both sides. I get 12, which equals 12. And you can divide. We usually show division as a fraction form, like this. If I divide both sides by 6, I get 2 equals 2. So you can do any math operation to both sides of an equation and the equation will stay equal. But you need to avoid doing an operation to just one side of an equal sign. There are a couple of exceptions. We can add 0 to one side of an equation without changing the equation. We can also multiply one side by 1, and that doesn't change the equation either. 0 is called the additive identity, and 1 is called the multiplicative identity. Other than that, you've got to do operations to both sides. Now, why is that useful? Our general strategy for solving equations as they get more and more complicated will be to use the inverse of the operation that you see to isolate the variable. What I mean is, we're trying to change every equation into this form, where the variable is set equal to some value, and then we know that that is the solution. So in this one, here's what we're going to do to show our strategy. We have add 78 that's keeping X from being isolated. We're going to do the inverse of the operation. So this is addition, we use subtraction. And our goal is to try to isolate X. But we can't subtract 78 from just one side because it won't be an equation anymore. So we do it to both sides. And that's basically transferring the mathematics to the other side of the equation where the hard work gets done. This is now equal to 0. X is still here. X plus nothing is still X equals -64. So X equals -64. Now, take the solution that you think is correct and check it by replacing X with the number you got for a solution. You check and see, is this a true statement? What is -64 plus 78? Turns out it's 14. So this is true, and you've checked your solution so you know it's correct. Let's try the next one. This represents division in this case. X divided by 17 equals -4. Let's rewrite this so we have a little more room. X is being divided by 17. The inverse of division is multiplication, so we're going to multiply both sides by 17. These 17s can reduce, and I have 1 times X, which is X. This is going to give us our solution, -68. Put it back in for X in the original equation. Is this true? And if you divide this, you do get -4, so this is true. X squared equals 144. X is being squared. The opposite operation would be square root, so we take the square root of both sides. But be careful when you do this. The square root of 144 has two solutions. So x can be 12, but it can also be negative 12. We often write this kind of solution this way. Finally, here's an example where the x doesn't come first. In all the previous examples, x was followed by an operation. I'm going to rewrite this problem as 23 plus negative 1 times x equals 19. So, we don't have an operation in front of 23, but we need to consider what's going to get rid of it. It's being added to x and it's a positive number, so we can subtract it to get rid of it. And we do the same operation on the other side to keep the equation balanced. So 23 minus 23 is 0. We have negative 1 times x equals negative 4. Now, since x is being multiplied by negative 1, we can divide by negative 1. That's the inverse operation. This reduces to positive 1 times x, which is x. Negative 4 divided by negative 1 is positive 4. Let's check and see if that works. 23 minus 4 is 19, so that is the correct answer. We use inverse operations to solve for x. You have lots of examples, so go try some.